Hi everyone! In this video, we will describe and create basic probability distributions. Suppose a nurse is administering a vaccine that has a 90% chance of success, meaning the patient gains immunity, and a 10% chance of failure, meaning the patient does not gain immunity. For each patient, let Y be a random variable that represents the total number of successful vaccinations if the nurse administers the vaccine to 2 patients. Construct a table showing the probability distribution of Y. I prefer to make a probability tree to help organize my information. So let's start with the first patient. We have 2 options. Either the patient gains immunity and it's successful, or the patient does not and it's a failure. The probability of that success is given to us as 90%, changed to a decimal as 0.9. And the chance of failure is given to us as 10%, which changes to the decimal 0.1. Now that's the first patient. The second patient has a combination with the first patient, success or failure, and the second patient can also be a success or a failure if the first patient is a success or failure if the first patient is a failure. And again, the probability or the chance of success is 0.9, and the chance of failure, again, is still 0.1. The chance of success is 0.9, and the chance of failure is 0.1. Now let's go ahead and find all of our combinations. We have success and success for the first 2, success and failure, and then failure, success, and failure, failure. And we can find the probability of those by multiplying the chance of success times success. So we get 0.9 times 0.9, which gives us 0.81. The success and failure is 0.9 times 0.1, which gives us 0.09. The failure and success is 0.1 times 0.9, which is 0.09. And the failure and failure is 0.1 times 0.1, which is 0.01. Now let's fill in our events that are possible. For Y to be the random variable that represents the total number of successes, we can have 0 successes, 1 success, or both patients are a success. If there are 0 successes, that means that both of them are a failure, and then we know that the probability for that is 0.01. Now let's look for 1 success. For 1 success, we have 1 here and 1 here. And so we have 0.09 and 0.09. We know from our conjunction that when dealing with probabilities, the word and means addition. So we need to add these 2 probabilities together. 0.09 plus 0.09 gives us 0.18. So 0.18 is the probability that the vaccine works successfully for one of the patients. Now for the probability that it will be a success for 2 patients, or both of the patients, which we already found is 0.81. Now let's verify that this is indeed a probability distribution with our 2 requirements. The first is that each of the probabilities is between and inclusive the numbers 0 and 1. Our probabilities are 0.01, 0.18, and 0.81. So they do indeed fall between 0 and 1. So our first requirement is finished. The second requirement is that the sum of all of the probabilities equal 1. So let's add our 0.01 plus 0.18 plus 0.81. Adding up all of our ones, or our hundredths of values, we have 1 plus 8 plus 1, which is 10, carry the 1. Adding up all of our tenths, we have 1 plus 0 is 1, plus another 1 is 2, plus 8 is 10, and we have 2 place values, or 2 decimal place values, so they do all add up to be 1. So we have verified that both requirements are met, and so our probability distribution is complete.